This is something I just simply also asked one of the famous, let's say, artificial intelligence on this planet right now, ChatGPT, if you take out my garbage, and I was not very satisfied with the answer I got, because it can describe how to take it out, it can tell you how to even sort it, but it will not be able to do so. And this is actually the moment where I like to announce AI needs a body. To actually be able to help us humans doing things we don't like to do, so we have time to do things we would like to do.
So, why is it so important, as I said? So we will have robots that will be capable of solving these complex manipulation challenges in the future. So they will be able to adapt, but they will be also able to handle things that they have never seen before previously. So this is what you can expect from the new ones. So this is the demo start, the second one. I told you with the dexterity, how the robot is learning to put some different stuff, autonomously, obviously. With the shadow gripper, yeah. As you can see, we still have a long way to go, but it's a good start.
I'm very careful in declaring the next industrial revolution, but the first time in my life, I feel it's worth to think about announcing the fifth industrial revolution is coming. Dear participants, to truly step forward to an Industry 5.0, we need the vision that goes beyond a 2 years ROE. We need to take action. And humanoids and other deep technologies are not just a tool to improve this or that process. They will be essential components for our future society. The race for physical AI has just begun. Switzerland and also Europe must play a role in this race.
What we did in the past is make a robot that is inspired from the salamander, that can swim and walk. And what we did is, together with neuroscientists, we developed a spinal cord model of the salamander. And what is interesting with just descending modulation signals, we could completely modulate the type of locomotion, swimming or walking, steering, and also the speed control. And this is really thanks to this system of coupled oscillators, which we have on board of the robot. And I think that's one of the beauty of this low-level control, is the high-level control doesn't need to worry about all the actuators. It mainly worries about higher level signals like steering and heading. And interestingly, this was done in open loop. There was no sensory feedback, and only input was from a remote control from a human operator, highlighting that in principle, you could be mainly CPG driven in such an animal.
First is, probably we need to be careful about the promises and expectations. So we need to understand the limitations of the current technology and should not overpromise. That is the first message. But the second message is we should also be very ambitious, as David says, because the technology and science does not progress linear. So it generally progresses non-linear, and we see step changes. And we know that it's possible to have acquired these intelligent robots at some point. And for that, we need to push forward. So those are the two messages. Thank you.
How do you envision the future AI, robotics, human for our audience? If it was one thing, what is it for you, André?
I think it will be the seamless integration of all these different systems. So we've been talking about AI, we've been talking about robots, about the human perspective. So if we also look forward from an industrial perspective, very much will be about the seamless integration of all these different kind of systems, cognitives, and so on and so forth. And therefore also really enabling this level of flexibility, dexterity, and of course also hopefully improved efficiency.
So when we think about a robot, so one of the challenges is to transfer the skill to the machine, but another challenge is to have the two working together at the same time. And this is what I wanted to illustrate in this slide. Here we have a robot that is compensating for the gravity. So we have a robot that looks as if there is no weight. So when we move it, we don't have the impression that there are motors. It looks really like something extremely lightweight to move. And here what we added is a mechanism so that the robot would point at the object of interest without having the user to take care about this aspect. So we have in this way a collaboration where this can typically hold a tool the tool can potentially be quite heavy. And the robot is here as a way to simplify the life of the operator, because the operator doesn't need to care about some of the aspects that it needs to control.
Scientists, right? We look into the data, we see that many things are converging. We love to always say 2030, 2045, 2050, because they're like sound nice rounded numbers. But definitely, at least what the facts and figures are saying, computer vision is improving, sensors are improving, like different kinds of technologies that are key for making humanoid more ready for interacting with us and for the environment where we work at and we live at, starting to converge. So hopefully in the next maybe 10-15 years, we're definitely going to see something that will satisfy our expectations, right? Which is another big debate, is like, what is a good humanoid robot and what is not? So
Thank you, Dave.
One of the biggest challenges is to first of all, to get the data in the first place. Because as I mentioned in my presentation, collecting data is one of the most expensive piece in the picture. And also, you need a lot of human developers and a lot of engineering hours goes into the picture. So having a mode of synthetically generating the data, the motion, and getting the robot trained on that front, I think that is one of the biggest challenge. And the second biggest challenge that I see right now, it's still an open question, is the sim to real gap. So trying to figure out the ways to reducing the sim to real gap, I think that is the next big challenge, I believe. NVIDIA is now bringing to the table is the 3-computer solution for this physical AI. So one is the DGX cloud. So DGX cloud is where the large language models are trained or the robot policies are trained. Another is the simulation platform, which is Omniverse with Cosmos. And what exactly has happened is the fact that, we let the robot train in the simulation instead of, getting the real world data set collection, so on and so forth, and let the robot train. We can gather a lot of synthetic data and use those models for training our models. We'll see all these things later on. And finally, having trained on lot, spending a lot on the infrastructure, then we need something to really to the robot to get into the physical world, and that's where the AGX come into the picture. These are the embedded supercomputers that we offer. For instance, Jetson Orin, or now which is coming.
You mentioned the iPhone moment, right? I don't believe in that, because the problem is, again, Apple is a closed ecosystem. We know it, right? And we don't need that in robotics. What we need, in fact, is more like a Windows moment, or even better, a Linux moment, right? An open source software, right? In order to control all robots. Because once we have that, then we can talk about data exchange. Then we can talk about connecting everything together. And we need that, and it's not there.
Thank you very much.